Okay, so here's question number 3, where we're looking at coat color in dogs. So we see that having black fur is dominant, and having chestnut fur is recessive, and then having a solid black fur would be dominant or solid chestnut, and then having oh, I wrote recessive here. Having spotted fur is recessive. So in our offspring that tells us 3 out of 8 are black and solid, I just converted the 3/8 into 6/16 because we're used to looking at like a dihybrid cross that has 16 squares. So it's easier to visualize this way. Then over here, all I did was write down what the genotypes are. So to be a dog that has black fur and a solid fur coat, you would have to have at least one dominant B allele and then at least one dominant S allele in order to give this phenotype. And so the rest of these are the genotypes for the ones listed. Now, here is something interesting. If you look at the numbers, so if we look at the numbers and we only look at one trait, let's look at the coat colors, black fur versus chestnut colored fur. So if we look at the math, we have 6 plus 6 gives us 12 out of 16. So 12, out of 16 are black fur. And then we have, for the chestnut, 4 out of 16 have brown fur or chestnut colored fur. So if we do the math here and you can just divide each one by 4, that would give us 3 to 1. This is a general 3 to 1 ratio. So if we remember from our simple Punnett squares, in order to get a 3 to 1 ratio, you would have to have 2 parents that are heterozygous for both traits. Oh, duh. So here we would have our chestnut offspring, and then the other 3 would be our black fur. So we have a simple 3 to 1 ratio for that. So most likely our parents are going to be heterozygous for the, at least for the coat color genotype. Now if we look at solid and spotted, we focus on just those two, what we see is, if you count up the solid phenotypes, here's solid, and here is solid, there's 8. So 8 out of 16 is half. Let's go over here. So 8 out of 16 is half, is solid, and 8 out of 16 is spotted. That's the other half. So in order to get a phenotype that would give us half spotted and half solid, you would have one individual, one parent, be heterozygous and one parent be homozygous recessive. So when you do your Punnett square, you end up seeing, here's a big S, little s, big S, little s, little, 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 little. So in our results, we see that these two are solid and these two are spotted. It gives us our observed 50-50 ratio. So our parents are like this. So we'd have one parent that's heterozygous for both traits, and one parent that's heterozygous for coat color and homozygous recessive for like spotted or solid. Now you could take, if you want, and take this parent and do a dihybrid cross to check it out to see if it gives you the 16 the 6 out of 16, 6 out of 16, 2 out of 16, 2 out of 16 observed results to double check your work.